This is experiment 3. It is on filter design. Now the topic is actually very important, filter design. So try to understand the concept very well. Remember that it is not only about creating a circuit on PSpice. Okay, building a circuit on PSpice is actually quite easy. It is not very difficult, but understand what you are doing and why are you doing it. That is more important. Okay, so let's start our discussion on filter design. Okay, so the first question, that is what is actually a filter. So let's understand the concept quite well. So for example, in our country we use 50 hertz signal. Okay, an electrical signal of 50 hertz. Okay, so let's try to simulate it first. Okay, go to your PSpice, go to file, new, and project. Okay, name the project the way you want. Okay, so let's say exp3. Create a blank project. Okay, so I have this. Now in the right column you can see place part. There you can find your components. Okay, you can just place in. So I am going to so uh, don't forget to connect the ground as well. Okay, now say I have this value. Okay, so let's make the offset value is 0 volt. Let's make the amplitude of my sine wave, let's make it 10 volt, and the frequency is actually what is 50 hertz that I was saying. Now I want to actually see how it looks like. Okay, so I want to see how it looks like. So let's start. Sure. Now I want to create a transient response for 100 millisecond. Okay, just apply it, then run it. So this is your output signal. Okay, here you can see this is actually in the x-axis I have time. Okay, and the y-axis I have the amplitude. So I took the amplitude of 10 volt. Okay, so I have a 10 volt is a signal. Now frequency is 50 hertz frequency. So you know that frequency 50 hertz, f is equals to 1 divided by t, capital T, that is your time period. So your time period here is 20 millisecond, right? So I have a 50 hertz signal, I have a 50 hertz signal of 10 volt. Okay, now let's look at it in the frequency domain. Okay, here you have FFT. So in the frequency domain means in the x-axis now I have frequency, not time. Okay, in the y-axis I still have my amplitude, in the x-axis I have frequency. So here you can see 0 hertz, 40 hertz, 80 hertz. So in the 50 hertz I have a peak because I was using a 50 hertz frequency signal. So when I actually what I'm actually doing is here is that I'm converting a signal from time domain, okay, into frequency domain. Okay, so my original signal actually, so if I actually look at like this, my original signal was a sinusoidal wave of 50 hertz. Okay, 50 hertz. So when I am actually converting it in the frequency domain, here I have frequency and here I have amplitude. I have only a straight line, a single straight line on 50. This is actually my 50. Okay, so I have a straight line on 50 hertz. Now in real scenario we don't actually have a straight line, rather I have a small, it's like this, a small, okay, like this, some other frequency components. Okay, normally it is like in our allowable is 49.5 to like around 51 hertz. Okay, so I have not a pure straight line, rather than I have something like this also. Now, so this is one signal. Okay, so I have a 50 hertz signal, and in the frequency domain it looks like this. So let's make it clear, okay, so that you can make it clear. Let's just assume I have only a straight line like this. Okay, so now say if I have another signal of 100 hertz. So if I have another signal of 100 hertz, so let's place it here now. Don't copy a component, okay, just try to add new one. Okay, if you copy the component, it will have the same name, then you will have some problems. You have to change the names and so on, so on. So it is better to actually take a new component. Okay, so let's take a resistor. I place a resistor here, then connect it. Place a resistor and connect it. Okay, offset is the DC value. Okay, I hope you understand those things. So the previous one I took was 10 volt, so 10 amplitude was 10. Now let's make the amplitude 20, make the offset value at stage 0, and I want to take the frequency a bit higher frequency, like say 100 hertz. Okay, now I also want to see the curve. You can see. Okay, now let's run it. So now you see in the time domain, again I have, this was my original, the 50 hertz signal. The red one I have, this is my 100 hertz. So that means I have, within half cycle I have twice the wave. Okay, because the frequency has doubled. Now if I actually look at the frequency domain analysis, in the frequency domain it looks like this. I have a 50 hertz, there is I have 10 volt on 50 hertz. In 100 hertz I have another peak of 20 volt. Okay, so this is actually converting a signal from time domain to frequency domain. Okay, now let's place another one here. Let's place another one. So let's take another one. Define. I place it here and place a resistor. Always place a resistor. Okay. 0 amplitude, let's make it 10, let's make it 30. Okay, and let's make the frequency a little bit higher, like say 400 hertz. Okay, now I place a probe. So I have 3 probes in 3 sources. Now let's run it. Okay, so you can see this my green one. Okay, that was my 400 hertz, so that is too much. And if you look at the frequency domain, you can see in the 400 hertz I have another peak. So what actually I am getting here, so I have a peak on 50 hertz. I have another peak on 100 hertz. The amplitude is